Yeah, it's loading up now. I hope my network allows this to go. So I think we're live on X and we're live on YouTube.
Awesome. Let's fucking
So
go.
yeah, let me make a post. So, yeah. Okay. So we have about 4 people on the call already on X.
hmm
You can follow that in real time, and I believe we're gonna have a lot more coming in. Let me quickly make a repost. So everyone gets to know that we started already, and here we go. Here we go, everyone. Welcome to the space. Welcome to the live stream. So yeah, it would be another very much interesting time, and we are being joined in the house with by Jonas Chen. Yeah, I believe I pronounced that right,
Let's
Jonas.
go. Let's go. Yes, I'm here.
Jonas, I believe you
I
can
think
hear me,
that's a
right?
delay. Yeah, I can hear you.
All right. So yeah. So we're going to be talking about building real time dApps, and we are going to be doing that with Magic Blocks, and it's going to be a high level conversation, and we're going to be looking at implementing the ephemeral rollups with we're going to look at implementing it on AIs, and we're going to look at implementing it with DeFi, high throughput DeFi applications, of course. And then we are going to be looking at, doing things around, gaming and, the whole gaming development and, managing and, working around with, that. And it promises to be an interesting adventure, and we're going to write code on the go, and we're going to see how to ensure that we have great submissions for the hackathon. So if you're building for the Solana Colosseum hackathon going on now, and you are not deploying magic block into what you're doing, I mean, a call like this would help you. And just so you know, we're gonna magic block is the that the presenter for the rewards for the consumer apps track of the Colosseum breakout hackathon. So it's very important that you're implementing, uh, magic blocking what you're building. So once again, if you're here, thank you for joining, and do retweet this, depending on where you're joining from. Invite someone to join in with you, and then I talk to another developer to talk to another developer that we have started. And yeah. And Jonas, you us, and we're gonna have a good time. So before while you're doing that, send in your retweets on X, and and then you first share the links. We are live on YouTube, we're live on X, and we will be running for the next 30 minutes to 40 minutes together on this space. It promises to be an interesting session. So while we're doing that, retweeting, sending in the interesting concepts, I would love if Jonas could probably introduce yourself and talk a little bit about who you are and what you're doing with Magic Blocks. Jonas, can you hear me?
Yes, can you guys hear me? All good? Yes? Can you guys hear me? All good? Give me a thumbs up, Odoka, if it's all good. Hello, hello. Can you guys hear me? Hello, hello. Test, test. Can you hear me?
You can go ahead. I can hear you.
Can you hear me? Everything good? Hello,
Yeah, you
hello.
can go ahead. Go ahead, Jonas. I
Oh,
can hear you,
all
Jonas. Go
right.
ahead.
All right, let's go. So welcome to the space with MagicBlock. My name is Jonas. I'm part of the MagicBlock team doing DevRel, developer relations. Today, I'm very, very delighted to have me here, an honor to have me here at Super Team Nigeria, sharing more about how to build real-time dApps. This session today, you will learn why you should build real-time dApps and when not to build, and then also what it is, what MagicBlock is, and how you can integrate your current application or your Solana program with MagicBlock. And I hope to cover this all within the next 30 to 40 minutes. I know some of you guys, or all of you guys, are submitting to the Breakout Hackathon. And here we are to support you. And that's why I'm here. Just one thing I want to mention before I go into this presentation. If you submit your project into Breakout, you should not forget also to submit your project to our real-time MagicBlock hackathon. This is concurrent, and you can submit the same project to that real-time hackathon by MagicBlock and earn rewards twice. So don't forget to submit on both hackathons. With that said, let's dive right into the topic is build real-time dApps with MagicBlocks. You might wonder why you want to build on MagicBlock and not just on Solana. You can see here, this is an application called Supersize. It's built on Solana. On the left-hand side, you can see it's just Solana, and on the left-hand side is just Solana, and on the right-hand side is on Solana with MagicBlock. And you can see a significant difference on the user experience. If you build dApps on chain, on Solana or any other blockchain right now, you are limited by the block time and the speed of it. So the users who interact with the database on the blockchain will have a laggy experience. They will need to pay for fees for every movement they do. And it's obviously not scalable at scale. So with that, you want to build applications where you require real-time speed, zero fees. You want to build that with MagicBlock. And you can do that very, very easily if you have already built on Solana. Just to give you some examples, what kind of application we are looking for when you build with MagicBlock. So there are a lot of applications. Maybe making one single payment is not the use case for MagicBlock, but the use cases for MagicBlock are real-time applications. Anything that needs high, super fast speed or like super low cost or zero cost for transactions and at scale, you would need MagicBlock. And the domains are here, for example, DeFi. For example, you guys maybe have integrated PIF, and PIF has this product, PIF Laser, that provides every 1 millisecond price data, price feeds to the blockchain. And here with the ephemeral rollup, you can utilize this 1 milliseconds of price data to your applications and deliver it to them. Here we also work with FlashTrade, one of the existing perps dexes. They are integrating. We're working with them to integrate ephemeral rollup or MagicBlock to the applications. Another domain is games. So this MMORPG that you see on the right-hand side, it's lag-free. If you would build it on Solana, you would have a similar experience, I mean, without MagicBlock, as you had with the previous application, Supersize. And if you want to record every logic, you need such a smooth experience, and that's what MagicBlock provides. It provides you the real-time infrastructure. We also work with in the field of DePIN and AI, and DePIN in particular with D-Telecom. They are open source, decentralized voice video conferencing tool that allows users to create rooms, to join chats, and that's fully on chain. What's on chain is here the matchmaking of the different rooms and who joins. And their problem is really the cost problem, not really the speed problem, where for every match, like a room they create, they would need to pay for transaction fees. And on the ephemeral rollup, you basically can do it for free and only put the final state of your matching room back to Solana. So these are the 4 or 5 domains, but it's not limited to that. What MagicBlock is, to give you a better idea, we see it as a highway for accelerated transaction. So while on Solana, you have this general purpose, this layer where execution and settlement happens in 400 milliseconds, a block is produced, right? You can have complementary, concurrently MagicBlock at the same time, building blocks sub 10 milliseconds, and always syncing the latest block to Solana. So with that, you can have state transitions in real time. What are the benefits that we provide? So one is real-time execution. We can provide near zero fees on ephemeral rollup or 0 fees, and it allows you to scale your application. As, for example, at peak times, your application needs more demand. You can easily spin up new ephemeral rollups to balance the workload, while at the same time benefiting from the benefits of being on the blockchain, which means being decentralized, being verifiable, being composable, being secure, inheriting the security of Solana, and also being unstoppable, meaning your application will live forever on the blockchain. So we really bring the 2 benefits of having the benefits of centralized server and decentralized blockchains. So just showing you some applications that we have built, some games that we have been building to demonstrate the success or like the benefits of MagicBlock. One is Pirate Nation. It's a nation where you have this ship and you cruise around, fight, and this is a unstoppable world that we are building. This world can never be shut down. Imagine there's no centralized server that somebody can turn off, and your assets that you're building on that pirate nation will stay there forever. Same for Heroes of the Sun. This is like kind of like a metaverse where we set out the economics of different resources and where players can build their own world similar to Minecraft, interact with it. And the benefit of this here, you can see, is everything that is set in this world is verifiable, not like on a centralized server where you don't know what the application developer or the game developer is actually setting up, what kind of, how many gold they have set, whether they tweak it or not, right? These kind of things, you never know what happens, and they can always increase the supply of money, the supply of grass, supply of water. But in a game that is on-chain, you can verify whether these limits have been set and are also enforced. Also, when it comes to composability of assets, if you want to transfer one asset from one game to another, this is something that you can only do in the decentralized blockchain way. We have another game here, which is eFrontier. In that, the cool part about this, it's like a world that you can build with all the assets and the game logic that is permissionlessly extendable. You can build like this whole world where these spaceships are cruising around on chain, and you can have different modes that developers can integrate open source and attach to that game, like a hardcore mode, a fun mode, or whatever. So this is something that also in the real world, you have difficulties building that and enforcing all the logic of being verifiable, composable, and unstoppable. One thing I want to mention about games in particular, there are games out there, most notorious Farmville, which was built on Facebook. What happened is Facebook turned on a fee switch where basically you have to pay fees for the API that the game has been using. And with that, the game was forced to cut 30% of the revenues as royalties and give it to Facebook. And obviously, if you build a game on chain, you can avoid these kind of platform risk that changes that Meta or like Facebook is enforcing to benefit on your users. Yeah, so these are the reasons why you should build on chain and why you should or the use cases also when you should use MagicBlock. So how you enter on this MagicBlock ephemeral rollup from Solana and exit, we use this concept of delegation. So before you can execute any transaction in real time and make state transitions in real time, you need to delegate the state account from Solana to MagicBlock. And we have a program on-chain on Solana, which you can interact to delegate your state account, a PDA, to a delegation program. When you delegate it, it will be locked. And with that, this state can be accelerated in real time on the firmware rollup. Once you basically have accelerated it, you can execute in real time. And on demand, you can commit the state on the firmware rollup and settle it back to Solana, or even undelegate, meaning you change the ownership of your state account back from the delegation program of MagicBlock to your original program. So you have full flexibility and you have full control on when to commit state, when you want to delegate state, when you want to change ownership. And you can do much more, like you can have schedulers, you have clocks where you can trigger certain actions on chain and so on. So these are things that you can customize with MagicBlock. And how you do that is quite simple. So you have probably already your existing program. And the only thing that you need to do in order to be compatible or to accelerate your program is to add a few lines from MagicBlock's SDK that we provide already. So we have already covered two options, like Rust Native and Anchor. For the Rust Native one, I mean, you will mainly use, I mean, in both cases, you will use the firmware rollup SDK. It's in Rust. But then you have specific modules like the CPI module, you can see here, which handles mostly the CPI calls on Solana when you delegate and when you undelegate the account, the state account. On Anchor, we also provide macros. So we have like a module for Anchor to make CPI calls on Solana, which makes your whole experience so much easier. You just need to add one line to a state account, and then you can delegate that account. Or you add one line on your program, just a macro, and then it's ready for undelegation. We have another module in the SDK, which handles CPI calls on the firmware rollup. So here it's called FM. With that, you basically call CPIs on a Magic program on the MagicBlock ephemeral rollup to basically commit your states from the ephemeral rollup back to Solana, or even undelegate your accounts, meaning changing the ownership back from the ephemeral rollup, from the delegation program to your original program. And also for Anchor, we have provided macros for you to easily do that. We will go into that code example very, very soon. Let me share with you some things that we have built to make the whole user experience much, much better, especially for developers, and to make transactions smarter. So meaning that when you submit transactions that are being accelerated or not, you don't need to do any modifications for those transactions. So let me show you how it works. So when the user client, sends a transaction to the RPC, okay, as a smart router, the smart router can detect whether this transaction should go real time on the firmware rollup and on Solana. And any RPC can leverage on the smart router capability. We will open source the smart router code piece, and we are talking to Triton and Trignode and Helios, where we integrate this smart router capability to basically for you to have one endpoint where all the transactions are handled. And this ensures for us that what we build is decentral, and this ensures that the states are global and you don't need to change anything. So let me show you. These are the life cycles that happens when you interact with the RPC and when you want to delegate and execute in real time. So here, you submit a transaction. It will either bring it to the Solana when you want to delegate, or if it's delegated already, it will bring it to MagicBlock. So that's the first part. Then, when you execute real-time the transactions, Once you submit it to the Solana PC, it can detect whether it's basically delegated, and then it will execute automatically on MagicBlock. You can, meanwhile, on demand, commit back or even undelegate back to the next block on Solana. And you can see here, while on Solana, you produce one block. On the ephemeral rollup, you can produce up like at least 40 times faster, 40 blocks. So let me show you how the smart router works. The smart router has 3 steps that it goes through to detect whether a transaction should be routed to the ephemeral rollup or to Solana. Number 1 is metadata. So you know that on Solana, when you submit a transaction with all the instructions, you have metadata, which basically has a list of accounts, public keys, whether these accounts that you're going to use in your program are writable or are signers. So what MagicBlock Smart Router, or what the Smart Router does is check whether the transaction has writable accounts, and then it will go through all the writable accounts. And then on the second step, it will then check whether the writable accounts are owned by the delegation program. If it's owned by the delegation program, that means the account has been already delegated. And if it's delegated, then it will route number 3 to the ephemeral rollup. If all writable accounts are basically not delegated, that means then the transaction should be executed on Solana, because none of the accounts that are delegated. So here, in summary, are the 3 cases that happens. So the case number 1, the transaction is executed on Solana. So user submits a transaction, all writable accounts are undelegated, so the owner is not the delegation program. Then the transaction will be executed on Solana and will be returned to the client. Case number 2, user submits, and then Smart Router sees, okay, the transaction, all accounts are writable, and all writable accounts are delegated, meaning owned by delegation program. Then this transaction will not be executed on Solana base layer, but on the ephemeral rollup. And once that will be executed on ephemeral rollup, from that time, the accounts and the states will be synced. So what will be synced will be undelegated accounts and newly delegated accounts. Very important fact is, when you delegate your account that you want to accelerate, that account is not cloned at the moment of delegation. It is only cloned once you basically submit a transaction on the ephemeral rollup. The third case is when the transaction will definitely fail, which is if the writable accounts has a mix of delegated and undelegated owners or accounts. Yeah. Okay, let me also go through the data flow for you guys to kind of like understand how MagicBlock works and how we make the synchronization of the states and what happens here. So when you delegate an account, you will need to send a delegation instruction to include it in your transaction. Obviously, the account that you want to delegate needs to be undelegated, so the owner is not the delegation program. What happens is on Solana, we will lock that account. You will change the owner of that state account to the delegation program, and that's it. All right. As said in the beginning, the delegated accounts are not synced yet when you delegate, only upon submission of a transaction on the ephemeral rollup after the delegation. So when you next time send a transaction which doesn't need any modifications, as if you would submit on Solana, but since your account is delegated, the smart RPC or like the endpoint will see, okay, it's delegated. That means it needs to be executed on ephemeral rollup. All right, then what happens is, on the first time, for those accounts that are delegated, they will be cloned, and also the undelegated accounts will be cloned. So that's where the syncing happens, where the data from Solana will be cloned on the ephemeral rollup, where we then have like a global state on the ephemeral rollup. Then if you commit, what happens is basically you send a transaction, which includes the commit instructions. the account needs to be delegated, and this transaction will be routed to ephemeral rollup since it's delegated, and it will schedule a commit with the magic program on the ephemeral rollup. What happens is the validator on the ephemeral rollup on Solana will then finalize or get the state finalized and update the state. During this time, anybody can permissionlessly challenge in a decentralized fashion with a proof to reject the state in order to make sure that that things are decentralized and they can be challenged. You can also undelegate the account, which means you basically commit the state to Solana, but at the same time change the owner from the delegation program to the original program on Solana. Yeah. So these are the 3 steps, and this is the delegation lifecycle if you want to integrate with MagicBlock. And that's how easy it is conceptually for you to accelerate your existing program. Let's take a demo, because that's what we're all waiting for, and that's where you can see the real magic happening. You can scan this QR code, but for easy access, maybe Udoka, you can also share this with them in the chat. It's basically, let me put it out.
You can just drop the link. You can hear me?
Yes.
Please drop the link on the comments, on our private comment. Let me share that to
Awesome.
our right
Awesome.
away.
Somehow I cannot join the chat. Let me share this in the private chat and also on Telegram, and hopefully you can share this with the rest. All right.
I've seen it. I'm picking it up now. Yeah.
All right.
Yeah, I'll drop that to everywhere that everyone says.
Awesome. Let me share with you. Yeah. So yeah, that's our GitHub repo. That's the link that I just shared. So you will end up here. We have some README to show you some examples. So we're gonna show you how to integrate with MagicBlock, accelerate your program with an example of one of the simplest example, which is the counter program. There are other programs inside that you can check out, Minter, dummy token transfer, and also like a randomizer, roll the dice. But we will go into today in Rust, and if we have some time, we also go into the counter for Anchor. All right, let me show you the visual code. Let me see, can I open this? Yes, awesome. So once you clone this GitHub repo, you will find these folders inside. And here, let's have a look into the Rust counter. All right, here we have 2 main folders, the source folder and the test folder. We're gonna mainly look into the source folder, which contains the program. Let me also show you what kind of dependencies we are integrating here. We have the Solana program, we have the ephemeral rollup SDK, which basically helps you to do the CPI calls to MagicBlock programs. And then you have Borsch for serialization, deserialization. Every program in Rust starts with the lib.rs or the main.rs. And here we can see we have some modules that we integrate, and every Solana program starts with the entry point. We have here the dependencies, we have here the entry point, it executes process instruction, takes in what every transaction needs as a program ID, the accounts. This is the account, the metadata of all the accounts for every instruction, and then the instruction data. Here we do a simple log, and then we execute the process. All right, so let me show you what kind of instructions we have. So we have here, you can see the process. It will go into it will unpack the instruction data. Let's have a look what the unpack does. So you can see it comes in. We have different instruction discriminator that we check. We have initialize counter, we have increase counter, which is the basic functionality of your program. Like, for example, your program, it could be a game, it could be a DeFi protocol. And for you to basically add the capabilities of MagicBlock, you need to add at least four more instructions. One is delegate. You have then commit and undelegate commit. These are the 3. And then one more is undelegate. And here you can find some others, which I comment out for a bit, just for explanation. So delegate is for you to delegate it to the delegation program. And then you can still use the same instructions that you had and execute it on ephemeral rollup, because the smart router or like the endpoints will take care of it. Here's commit, basically on the ephemeral rollup. This instruction is only, these two instructions are only executed or processed on the ephemeral rollup and can only be processed there, committing the states or even undelegating the states. And this one is very, very important here. This is the undelegate instruction, which is executed on Solana. Basically, it changes the ownership from the delegation program to your original program, and it's called by the validator. It will call a CPI into it with the seeds of your PDA, and this seeds will basically be caught up by once you delegate, you need to provide the seeds, and it will know the seeds because it will be stored in a buffer account or like a metadata account where the validator can access and do the undelegation through the CPI call. And here you can see this discriminator is unique and constant. So if you undelegate, you want to add this feature, you need to have exactly this discriminator. While these ones are flexible, and I'll show you why later. Here, these two instructions are basically, you can do things like you can increment and commit, increment and undelegate. So you can atomically add other logic into your informal rollup execution before you make a state commit or like an undelegation. Let's go back to the processor. So here, I don't go through the basic functionalities, but some checks. It will check whether it exists, the state account. If not, it will create an instruction to create an account with the system program, and then it will change the owner to the delegation to your program. And here you will set and initialize the account to 0. And yeah, here the increase counter, same thing, goes through account, do some checks, and it will increase by the value that you passed in, which is the increase by variable. Okay, these are the basic functionalities. You guys have already said could be different basic functionalities. In order for you to delegate, we have this CPI, the function that triggers a CPI call. So if you go up, here are the functions that we import from the rollup SDK. And then you have this iteration of the accounts. You define the seeds, which PDA you want to basically delegate. This is basically the order of the accounts that need to arrange before passing into the function here that makes the CPI call. And you have a delegate config. Basically, it allows you to fine-tune some automatic commits. Here you can see commit frequency milliseconds is 30,000. That means that once every 30,000 milliseconds, auto commit will be triggered from the firmware rollup to Solana. And here you can also define a validator that you specifically want to target for the firmware rollup. Yeah, so that's the delegation. The undelegation, as I said, is fixed. This will be called by the validator. It will get the PDAs automatically and pass this in. The seeds and pass it in. And with this undelegate function, it basically does a CPI call to change the owner from the delegation program to your original program that was initially owned, which was owned by the PDA. So then we have here two other functions, commit and undelegate. So here you can see commit and commit undelegate. The functions commit accounts and commit undelegate accounts are imported through this FM module. So these are the functions that are, or the CPI calls that are only happening on the firmware rollup. Since your program is copied or cloned, when you delegate or when you make the first transaction on the firmware rollup, so we'll clone also these commits to the firmware rollup. So here you can see there's iteration. It will check whether the signer is the one who actually initialized that PDA or the state account. And then you have here the commit accounts, which basically schedules a commit to, synchronize the state from the firmware rollup to Solana. And then you can see we use different programs here, Magic Program, Magic Context. Same for undelegate. Here we use this function, which basically also triggers the transfer of owner from the delegation program to your original program on Solana. And then here you can see the atomic transaction instructions also, where you increment and commit. Basically here, increment and commit, or increment and undelegate, increment and you undelegate. Yeah, so these are the instructions. This is the program logic. Obviously, we have here also some states defined, where we have the count for serialization, deserialization, where we use Bosch. And yeah, that's it. That's how you basically add the capability of upgrading with MagicBlock and real-time execution. I'm gonna, you just do cargo build BPF to build this program. Cargo build BPF. Oh no, yeah, sorry, I need to go into the Rust counter and then cargo build BP. Cargo BPF. Oh. Well, SPF is SPF now. Okay. SPF. Yeah, it's already built. And then you have this target folder where you find this deploy folder. Here's the key pair of the program. And on you have the file, the byte file for deployment on Solana. If you want to deploy, you just Solana program, deploy, and then you target this deploy folder where the Rust counter program is, and then we just deploy it. Obviously, we need to make sure that we are on, one is on the DevNet here, which we are. And now here we have some authority issues, program authority. Oh, it was a different authority that I used to deploy. So it's a bit tricky right now to deploy it again. But you can deploy it if you have enough SOL. So I have enough SOL here with Solana balance. You can check that. Oh, I don't have enough SOL. So yeah, that's the problem. Let me see here, DevNet. I'm actually not on DevNet. I'm on DevNet MagicBlock. Let me Solana config set URL DevNet.
I was
Let me
thinking
here.
you
Yeah,
want
here.
to use. Can you hear me?
Yes, Odako.
Yeah, I was thinking you want to use your actual main net tokens to demo for us,
Oh, yeah. If I'm rich enough, yeah, I will do that. I will airdrop you some magic blocks and yeah, help you guys to sponsor your programs. Yeah, here, yeah, we have deployed this program here,
I see it.
and then we can run some tests. So I have here some tests where we just run a few tests. Basically, I have connection. Like, let me quickly run through the tests here also with you. So these are the tests. I have initialize counter, increase counter, delegate the counter, increase counter on the firmware rollup, commit the counter state from the firmware rollup to Solana, increase counter on the firmware rollup, and then undelegate it. And what I do here is basically I import my key pair, or I get the program ID from the key pair of the deploy or folder. Then I set the different connections that I need, one to submit transactions on DevNet, the other one on ephemeral rollup. Right now, our smart router has not been implemented yet, but it's soon up. It should be up this week, by the end of this week. So yeah, then you don't need to have different endpoints. You just have one endpoint. Then here we kind of like initialize our key pair to pay for transactions. We airdrop some SOL if we don't have enough to pay for the transactions. Here we define the counter PDA. These are the seeds. And then we can run the test with yarn test, and we can have a look what happens. Actually, I run here. I have also another test, but for now we ignore that. So on normal Solana, we have here on DevNet 6 seconds, 6,000 milliseconds to initialize. We have 3,000 milliseconds to increment. We delegate 4,000 milliseconds. And then, as always, there's some errors. The reason why is we have just deployed the program, and it takes some time for it to be cloned, and it would clone the first transaction. So I do another test, and then this should solve the problem. You can see here it's a bit faster than before, 2,000 milliseconds to initialize, 6,000 millisecond increment, delegate 2,000 milliseconds. Increment on the firmware rollup is 1,000 milliseconds, and 1 second is still quite long. Commit 500 milliseconds. Being finalized on Solana takes another second. I mean, it's here in this case, it's double the speed. The reason why you see such high, how to say, delays or latency is because here we not only have the block time, but also the end-to-end latency when you submit a request and then when the request comes back from the server. In order to see the true speed, we can also run a local host. Basically, it resonate, or it kind of like sets up like the nearest validator, which is on your own computer. So how I can do that, I can have a quick look into the README. So what you can do is you can install a validator, your own ephemeral validator on your local host with npm install. And then after that, you can, I have already installed it, so it should be quite fast. After that, you can run the ephemeral validator on your local host with this command. You can see here it's on port 899 and it's set up. And then I can run the tests by pointing to the ephemeral validator on my local host. And here you can see a huge difference, or you're supposed to see a huge difference. So we submitted on Solana base layer, and you can see here, delegate 1 second, increase counter, increment takes 500 milliseconds because it needs to be cloned from Solana to your validator here. And then you can see here the other transactions at 18 milliseconds, 71 milliseconds, 6 milliseconds, 5 milliseconds. Yeah, that's so much faster compared here to 1,500 milliseconds, and 15 milliseconds is 100 times faster. Or if we compare it with 6 milliseconds, it's 200 times at least faster with the ephemeral rollup. And with that, you can really create like real-time experiences for your application. And I just want to quickly show Anchor, and then we are done. Do we have enough time, Udoka, for the Anchor part? Yeah.
I was about coming in, and I was about telling you, like, could we be, wrapping up or something like that. But this is the thing here. What I think is important is that this hackathon is ending up in the next 2 days or thereabout. So I believe we can stretch it if you can show us, everything that we need to know, and not have to, try to manage time. Because you made mention of the is it the side track for Magic Blocks or the Magic Block hackathon itself? I would want you to talk about that when you are done with the demo. But again, since we have these things up there, and we need to get it right. So I think we can go along, and you can go on with the anchor test. We need to just see everything that needs to be seen, and then we don't need to like try to cut things up, or you get what I'm saying, yeah?
Yeah. 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 No problem.
So let's go. Let's do
So
the anchor.
yeah,
Let's see it. Let's see
let's do
it
the
right.
Anchor.
You can go.
Okay. Thanks, Udoka. Yeah, so Anchor, so if Rust was very difficult for you, no problem. Anchor is super easy. So here again, we have different, here are the dependencies, Anchor lang, obviously, and the ephemeral rollup SDK, and that's it. if you look into our program here, we have here the imports, we have our program, and you can see here we have the different functions, initialize and increment, basic function for a normal counter program. And then we have here 4 more, or actually 6 more, 4 more other functions: delegate, commit, undelegate, and that's it. And then we have some other 2 where we increment and commit, and increment and undelegate, which basically allows us to atomically increment and commit the states. But yeah, these are the 3 instructions that are that you have to define, and these are the imports that you have from the dependency. So you can see here there's one ephemeral macro, and what it does is it creates under the hood another instruction, the 4th instruction, which is the undelegation, which is called by the validator when you undelegate your PDA. So by adding this, it will basically make it compatible for undelegation, and it said it will create this 4th undelegation instruction. Yes. You can see here this undelegate is a different undelegate than the one that you see on Rust, because this undelegate actually is the undelegate triggered on the firmware rollup. You can see here this is the function that is called to sync another undelegate on the firmware rollup side, same as here, just commit. Okay, then the second thing is about the accounts, the context. So here, in order for you to basically have the right context, you have your normal accounts and you just add the macro delegate, and it will basically settle everything for you to delegate. So here you can see once you put the delegate macro, in the end you can utilize a delegate accounts.delegate, whatever name you want to give, delegate PDA, delegate whatever account you want to delegate, and this will basically call the function for you to make a CPI call. And you can configure your delegation configuration, basically the auto trigger for commits from ephemeral rollup to Solana, or even a validator. You can also just set a default here, and that's it. And then you have also this commit macro, which allows you, basically it adds, because that's triggered again on the ephemeral rollup side, and that will basically add the magic program and the magic context to your context under the hood. So you don't need to change anything here. So that's what you all need. And the test is the same. You just run anchor test, and you can see it should work. So if I run, after you build it, obviously, I don't want to deploy this again because it's already deployed. I just want to show you that we can run these tests and it works. Where's the test? Yeah. Oops. cd anchor, counter, and then here you go. Same thing. This is on DevNet on MagicBlock. And then we can also later run it on the firmware rollup, since we have set up the firmware rollup already on localhost. We don't need to set up again. But here, just comparison, 2,600 milliseconds. Here you have 1,300. So it's at least 2 times better. And if you do it on the local host, the tests are the same as on the Rust counter. You can see, again, 40 milliseconds, 9 milliseconds, sub 10 milliseconds that we can achieve here. So significantly faster. Just to give you also like a UI to play around. So this is the counter program anchor deployed on DevNet using an UI here. So if I want to increment it, it takes a while for the transaction to confirm. But when you delegate it, you just delegate it to the firmware rollup. It clones the account. And then if you submit your first transaction, it will be cloned. And then subsequently, it should be much faster. You can see the confirmation just pops in. And then if you undelegate, it will bring it back. And you can see it's so much slower, yeah. And then you can go fast, crazy fast here, yeah. Yeah, so yeah, that's it for the demo. I wanna just quickly share about um, the call to action for you guys. If you want to build on MagicBlock and you have some issues after me sharing this demo and the guidance with the counter program as an example, please join our Discord and also follow us on Twitter to stay up to date. And you can like send any questions. You can even jump with me or with Gabriel and Andrea, the founders of MagicBlock, on a call so we can give you feedback on either the idea or the technical implementation with MagicBlock. And just a reminder, we have not only breakout to submit, but you can also submit on the real-time hackathon of MagicBlock. If you go to our MagicBlock website, you can find it on magicblock.xyz, and just submit the same thing and you get rewarded twice. The only requirement here is you integrate with MagicBlock. Yeah, that's it on my side, Udoka. Thanks for listening, guys. Hope I didn't drag it too long. Udoka? If you guys have any questions, yeah, leave it in the comment. I'm happy also to answer that.
Yeah, yeah, yeah. You can hear me, right?
Yes, I can hear you.
All right. Thank you so much. Thank you so much, Jonas. This is what I wanted. Yeah, I wanted. I looked into what's being done with MagicBlock, and I wanted a lot more people, in our community to, get to, hear this and say this directly from an insider, and you did justice to that. Thank you so much. And yeah, you didn't drag it so long. We kept to time. You started
Awesome.
about 40 minutes ago, if I'm yeah, about 40 minutes ago, and the duration was like 40 45 minutes, and you did just that.
Awesome.
So yeah, I'm
Awesome.
sure
I'm
that
very
there would
happy.
be a lot. Yeah, 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 you do, you should. There should be a couple of questions, and I'm very much particular that after now, you know on implementation, there might be some more questions in our hacker house right now. We still have some people downstairs that have some problems that we are going to deal with or look into tonight. But I don't want to drag you further because I learned it's about 1 a.m., 2 a.m. now in your place.
No problem. Yeah, it's all good.
Yeah.
I'm here to support. By the way, Udoka, I sent you also the link for the real-time hackathon submission. If you wanna share this also with your community, this is where the people can submit. I
Yeah,
just sent
yeah,
it in the private chat. I also send it again in Telegram in
I
case you
will.
can find it. Yeah. I can't see the chat right now, but if there's any question, maybe you can read it
Yeah,
out
I
for
can
me.
find that. I can find that. I would share that. I would share that right away with the community. So for the
Awesome.
all right, fine. I would reach out to you. I would reach out to you for any form of support. I believe you can hear me, right? I lost you for a second.
Yeah, now I can hear you. Yes. I mean, we can do some answering now if
All
there
right.
will
So
if you
I'll reach
want,
out
or
to
you
you.
can we can do it on Discord.
Okay. If there's not too much to ask for you, um, let me see the comments if we have any questions right now on the comments. Show comments. I think basically we would have a lot more questions on implementation, not just after this call. So
Okay.
people would basically have things to talk about when they tried out something and it doesn't work properly or something like that.
Yeah.
So yeah, I'm very much available, and I would do well to see how to, even if it means setting up, some kind of small talks where you look into projects and then we can work around solutions together, and then we can run with it. So basically, I will share this link. Can you quickly talk about the hackathon, the Magic Block hackathon, before you hop off? Because I believe there are some really interesting games in our community, and then these guys would be submitting probably for the gaming track in the Colosseum and would not be able to submit for the consumer apps track, which MagicBlocks is actually sponsoring. So I believe that these people would also want to submit in the MagicBlocks hackathon because we have a lot of interesting applications, high throughput DeFi applications, and really really good AI products as it stands. And all of them are going live on this, are going to market on this hackathon. So can you talk a little bit? Okay, I see you are sharing the screen already. So is
Yeah.
this? I learned it's ending on 16th. Is it ending like in 2 days time as well? Can you just maybe
Yeah,
share a
it
little
has.
bit on that before we hop off?
Yes. So it has the same deadline as the breakout hackathon. So you can really just use your program or your application and submit it to both when you use MagicBlock. So here, just to let you know, we are the sponsor of the consumer track. So if you submit a consumer, we definitely can, like evaluate with MagicBlock since you integrate it and your application, your project. However, if you submit on games, we do not have so much flexibility on that. So I highly recommend you, if you build a game, submit it on both on the breakout games track and also on the real-time hackathon here with MagicBlock, where we have our own prizes, where you can win up to $20,000. And yeah, just submit it here and we can evaluate also your game with your MagicBlock integration. And please share your project, not only with us, but also with Odoka and the community, so we can see you. Please be active on Discord and share about your project, because then we can see it. And please also schedule some meetings with us if you need any help or some feedback, so we can see it again and we can help you to succeed for your hackathon. I know it's just a few days of or 1 day left, but we really want you to succeed. And the integration of MagicBlock, as you saw it takes less than, I would say, 10 minutes on Anchor, or a little bit longer maybe on Rust, maybe half an hour for you to implement it. But yeah, it's really the last thing that you do to add this real-time feature to your app. That's it. Odoka?
Yeah, yeah. You can hear me, right?
Yes, I can hear you now. Yeah.
Jonas, can you hear me?
Yes, I can hear you.
All right, I think someone is having issues from YouTube. I just saw that there's a viewer from YouTube who has issues with implementing with Anchor. The comment says, please ask for implementation with Anchor. I'm struggling to set it up. So I don't
Ah,
know what could be the specifics for that. I wish the question or the comment was more specific on what area the struggle is at.
yes, no problem. Yeah, make sure so that's a good point. There may be some issues regarding Anchor versioning. So make sure you check your TOML that you have the right versioning here. But also on the README, you need specific versions for your Solana and also your Rust and Anchor. So just make sure that you have the right versions installed on your computer before you build your program. There's always like these versioning issues, since things keep changing very fast on Solana. That's why we are becoming also so fast. So yeah, we just need to adapt also as dev on that.
All right. Um, okay, so I think yeah, things move really fast on Solana, and yeah, we're moving as fast as that. So I think Daniel still okay. This is Daniel now. Okay, it's still Daniel earlier who said I ran the example code and still couldn't build it. So like Jonas said, I believe you can check on the versioning properly and make sure that it is the same with the versioning that is listed here in the README, to ensure that, because one thing with Anchor is the versioning is very important. It's very 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 important that the versioning is proper. So you have to like check that effectively, or check that properly rather. And I don't know, I'm not saying another question at the moment.
Yeah, in
So
case
yeah, i
also
think i
Daniel,
think this
if
way.
you
Okay.
yeah, in case Daniel, if you still
Okay, all right.
struggle, just join the Discord. and also put the error that you have there in the Discord, and we will help you to get it fixed. So just yeah, let us know. Sorry to interrupt, Dako.
No, no, it's fine. It's fine. That's really thoughtful. I mean, the Discord thing. I mean, you have a couple of developers there who would be ready to jump on fixing whatever bug it is that you might be encountering. Also,
Awesome. Thanks to Dako for organizing this awesome community call, and really appreciate having me here and
and I
having you
would
here in the community.
share it. Thank you so much for joining in. So I believe without much further delay, let's be calling it a wrap. It was beautiful doing this with all of you for the last 1 hour. I'm seeing on my radar here about 213 people have been on this stream, and it's about 1 hour now. So thank you so much, guys, for coming, and much more appreciation to Jonas. Jonas is joining in from a time zone that he's supposed to be resting now, but he managed to make out time for us. I really appreciate this. Thank you so
All
much
the
for
love for
coming
you.
in, Jonas. And it should be 3 a.m. It should be 3 a.m. or 2 a.m. where you are at now. I really appreciate
Yeah,
this
Singapore.
sacrifice.
I'm dialing in
So
from
thank you so much.
Singapore.
And
Best greetings.
yeah. So yeah. Thank you so much. And you can go to bed and have a good rest now. And we can talk when you wake up. All right. So yeah, that will be all, guys. I will be wrapping up now. Thank you so much for joining in. If you have any questions, any do well to uh you can rewatch the video. The video is on my YouTube channel. You can rewatch the video from the start to follow on properly if you didn't join from the beginning. And if you joined, and you're having issues with certain things you didn't catch properly, you can rewatch the video and believe you would get it right. Join the channels, the Discord, um, and then you can shoot me a DM. You can shoot Jonas a DM, and if you're on any of the super team communities, the product community, the developers community, just do well to talk about what you are facing there. I'm there, and I would do my best to ensure that we do what is needed to be done and we ship properly for before the hackathon comes to an end. So yeah, once again, thank you so much for joining in, and I'll be wrapping up now. Yeah, bye guys.